So this video is going to be a review for us of why we use dimensional analysis. So in the process of dimensional analysis, or converting between units, we are looking for a way to make sure that we can efficiently and correctly change between one unit type and another, which is what conversion actually means. Conversion means to change. So in order to understand what's actually happening during the process of conversion, we need to understand that when we are using something called a conversion factor, we're actually looking at a relationship, a known relationship, that exists between units of different types. And those known relationships are equalities. So the two components are equal to each other. And our example here is something that we're pretty familiar with, which is 1 foot is equal to 12 inches. So the way that I like to think about this is, we know, right, 5 is equal to 4 plus 1. That's an equality relationship, just like 1 foot is equal to 12 inches. If I take this equality and I make it into a proportion, in other words, I turn it into a fraction, and I say, if I had 5 and I related it to 4 plus 1 in this proportional relationship, or this fraction, if I solved this, my answer would be equal to 1. Because the two quantities are equivalent, it's the same thing as saying 1. Now that's important because when I want to convert between units, I can't do something that's actually going to change fundamentally the quantity of something that I have. So in order to be able to change my units without altering the quantity, I need to use something that we call a factor of 1. So in this case, 5 over 4 plus 1 is a factor of 1, or is like 1, because the top, or the numerator, and the bottom, or the denominator, are equivalent to each other. So I can also write 1 foot, and I can put that in relationship to 12 inches. And because those two things are equivalent, they are the same quantity, those would also be factors of 1. So any conversion factor that you're going to use in the process of changing from one unit to the other needs to be equivalent in both the numerator and the denominator, so that you are in fact using a factor of 1. So there's a variety of circumstances in which we can use conversion factors, okay? One of the sort of the common ones that you're going to come across, particularly with respect to the Regents exam, is going to be changing between units in the same metric base, right? So if I'm looking at going from kilograms to grams or something of that nature. In order to do that, I need to know what the power of 10 relationships are to the prefixes. And that's going to be found on table C of our reference table. We need to memorize those, and there may be a few other prefix and power of 10 relationships that we'll need to learn. But the important thing is that when we are looking at this method of conversion, the key is, when I'm going from one factor of 10 to another factor of 10, is I'm looking for the difference between the two factors, and that's how I'm going to know how to create my conversion factor. So for example, when I'm talking about finding the difference, let's say I want to go from kilograms to grams. I need to know that kilograms is 1 times 10 to the third. That's the power of 10 that's related to kilograms. And grams, which is the base unit, is 1 times 10 to the 0. When I talk about finding the difference, what I'm talking about is finding the difference between the exponent values. And I'm not interested in plus or minus at this point. What I'm just interested in is actually how many decimal places different are 10 to the third and 10 to the 0. And in this particular case, we're talking about 3. There's a difference of 3 decimal places. And that's going to be important for us when we go ahead and we look later at how to use that. I'm just going to move this up a little bit. So another thing that's important, right, is if we know that 1 gram is equal to 1,000 kilograms, right? That's another equality, very similar to what we were talking about above. So again, we can use these kind of relationships to create proportions that are equal to 1. So again, a factor of 1. Another way that we can use this method is by converting between two different types of measuring systems. So the imperial system, or the English system, which is the system that we use here in the United States for non-scientific purposes, often requires that we convert that, so something like feet or inches or miles, into metric system units like centimeters or meters or kilometers. Again, we need the relationship that is going to allow us to do that. And most of the time you are going to be given this relationship. So you're not going to need to memorize what the relationship is between imperial units and metric units. So for example, let's say that I want to go from yards, which is an imperial unit, and I want to convert that distance, yards is a measurement of length or distance, I want to convert that to kilometers, which is the metric system, also a measurement of distance. There's a relationship, a known relationship, that correlates these two things together, and that is 1,093.6 yards is equal to 1 kilometer. Okay, so again, we have an equality here, which is relating two quantities that represent the same amount. And if I were to put these two quantities into a proportion, this would be a factor of 1. So no matter how we're using this, no matter what we're attempting to do in terms of dimensional analysis, my conversion factor, which is represented in this particular case here, right? This is how I convert between yards and kilometers back and forth, is equal to 1. By the way, an important notation is that if I write this the other way, if I write 1 kilometer over 1093.6 yards, right, that's still equal to 1. Because if we think back to our example from the beginning, if 5 is equal to 4 plus 1, 5 over 4 plus 1 is equal to 1, as well as 4 plus 1 over 5. Right? So both of those things are equal to 1. So conversion factors can actually be used in either orientation. Right? I can use the factor that I wrote the first time or its reciprocal. So I can use a conversion factor in either orientation. And that's going to allow us to really get full use out of them, because maybe it's not always going to be lined up that I need yards on top. Maybe I'm going to need kilometers on top at some point as well. We can also use dimensional analysis to convert between units within the imperial system. We do this a bunch. I mean, I certainly do this a lot when I'm cooking. I love to cook and bake. And sometimes what happens is they're giving me an amount that I need to change from, let's say, ounces to pounds. Both of those are imperial units, okay? And I might say, okay, they're telling me that I need a certain number of ounces of meat, but they don't tell me about ounces in the store. I need to know how many pounds of meat I'm supposed to buy, and so I'll do a quick conversion on the fly. Of course, I need to know that there are 16 ounces, abbreviated lowercase OZ, in 1 pound, abbreviated LB. And then, of course, if I know that, then I can set up a conversion factor of 16 ounces per 1 pound. So that's another way to say it. That line sometimes is referred to as per. these numbers are equivalent, and therefore this is a factor of 1. So if they told me that I needed to have 32 ounces of meat, and I needed to know how much that was, and we're going to go through this again in just a moment, I'm going to take the information that I have, which is I have 32 ounces, and I'm going to use my factor of 1 written in such a way as I can get rid of my unwanted unit. In that case, my unwanted unit is ounces. And then I do some math, and if my math is correct, I'm actually going to need 2 pounds of meat. Okay, so this is an important skill. Maybe I don't actually write it out on a piece of paper, but this process is something that we can use in our daily lives. So let's take a look at our practice situations. So a couple of things that I want to point out. First of all, my little note, my little rule, my little star here is always start with the given information. And what I mean by always start with, I mean when I start setting up my numbers that I'm going to be using in the process of multiplication, so I'm multiplying fractional or proportional relationships together in order to get my end result, I want to start with what's given to me. So in this first circumstance, I'm being asked to convert from 12.3 millimeters to meters. So how many meters is 12.3 millimeters? So again, as a reminder, when I'm converting between metric units and I'm simply going from powers of 10, I need to know what my powers of 10 are. So millimeters is 10 to the minus 3. Meters, which is our base unit, is 10 to the 0. And I'm looking for the difference between those two numbers, and the difference is 3. Okay, now that's going to be important. We're going to see why in a moment. So here I have my given information, 12.3 millimeters, and I'm going to put that over 1. And the reason I'm going to do that is because, first of all, it doesn't change the quantity that I have, but it helps me to orient my numerators and my denominators well. Now, in order to get from 12.3 millimeters to some amount of meters, right? I want my answer to be in meters. I need to arrange my conversion factor, which is going to go in this next bracket, so we're multiplying our given times our conversion factor. I need to arrange my conversion factor so that I get rid of the millimeters, right? I don't want millimeters, I want my answer to be in meters. So how I do that is, if I have millimeters in the numerator, I want to make sure I have millimeters in the denominator of my conversion factor, because I want to be able to divide millimeters by millimeters and get 1, and therefore I don't have that unit any longer. So I'm just going to write my relationship here, millimeters and meters. Now, you can put your 1 times 10 to the power of 10 either in the numerator or the denominator. It's up to you. I usually like to do it at the top. So I'm going to have 1 times 10, and then over here, my difference becomes the number that I'm going to write my power of 10 to. Try to make that slightly clearer. 10 to the 3, all right? And then I'm going to have my other component here be 1. Now, I'm not quite done yet, because my job is to then analyze this relationship and say, does this relationship make sense? Are there, in this case, 1,000 meters in 1 millimeter? In other words, are there many meters in a millimeter? Or is there a fraction of a meter in a millimeter? I think we all agree that a meter is much bigger than a millimeter, so it would need to be a fraction of a millimeter. And the way that I indicate that this is going to be fractional is by putting a minus sign in front of my number. So 1 times 10 to the minus 3 meters, or 1,000th of a meter, equals 1 millimeter. And we know that that is, in fact, the correct relationship. So then what I'm going to do is I am going to carry through my math in order to answer this question. So the first thing that I need to do is multiply 12.3 times 1 times 10 to the minus 3. And if I do that, I can use a calculator for this. I'm going to get 0.123 meters. And then looking at that, does that make sense? Does it make sense that I'm going to have a smaller number of meters or a smaller quantity for my number of meters than I have for millimeters? Yes, that makes sense. Now, by the way, if we look at this, right, not only am I multiplying across the top, I'm multiplying across the bottom, and then I need to simplify. And in my process of simplification, I divide millimeters by millimeters, and they become 1, right? And if they become 1, then I can now ignore them, and that's how millimeters disappears from my equation. So just in terms of follow through and looking at another example here, we're just going to look at 6.0 times 10 to the 5th milliliters. So again, milliliters, milli is 10 to the minus 3. And I want to go to kiloliters, and kilo is 10 to the 3. The difference between those two is 6. So my power of 10 is going to have a 6 in it. I'm going to go ahead and I am going to set up my relationships, first starting with my given information. So 1 times 10 to the 5th milliliters, putting that over 1. And then I'm going to arrange my conversion factor so that I can change from milliliters to kiloliters, meaning that I need milliliters on the bottom and kiloliters on the top. I do my 1 times 10 to some power in the numerator. You can do it however you want. This is going to be to the 6th. And we're going to evaluate whether we need to the 6 or the minus 6 in a minute. And this is going to be 1. Then, right, we're going to do the same thing. Does this make sense? Are there 1 times 10 to the 6 kiloliters in 1 milliliter? Meaning, are the kiloliters smaller than the milliliters? Of course not. Kiloliters are much larger. So in order to make this a factor of 1, I have to say 1 times 10 to the minus 6 kiloliters is equal to 1 milliliter. And that is in fact the case. Okay, and then here we go. We're going to do some math, and we're going to wind up canceling out our milliliters, being left with kiloliters, which is exactly what we want, so that's good news. And then I'm going to get an answer of 6 kiloliters. Okay, same idea. If I want to do metric and imperial units, I need to know my conversion factor. This is not something that you will have to memorize. Okay, so this is good news. You can get this information. It'll be given to you, or you can look it up. So in this case, I'm going from inches to centimeters, and the relationship that I'm going to use is 2.54 centimeters is equal to 1 inch. Okay, that relationship then turns into my conversion factor of 2.54 centimeters per 1 inch, right? Remembering that this is equal to a factor of 1. And then I can set up my relationship just like I have in the previous 2 examples with my given information first. So 12 inches over 1. Then I'm going to set up my relationship. I want inches on the bottom and centimeters on the top because I want inches to cancel. I'm going to have 1 inch because that's what I have over here in my relationship, and 2.54 centimeters because that's the other component of my relationship. And then I can cancel my units that I don't need and solve the answer in the units that I do need. And if I do the math for this, I'm going to get 30.48 centimeters. So this is sort of what you're doing if you're going one step at a time, or one conversion, easy conversion factor. But sometimes we're not able to do that. So when we start to become more complex, right, we're going to have multiple steps or multiple units involved. We need multiple conversion factors in order to help us. Okay, so here I'm going from seconds to years. So I'm giving this to you, and let's say I'm not letting you look anything up, but we know a bunch of relationships about time. So I'm just going to write my relationships over here. 60 seconds is equal to 1 minute. That's a relationship of time that might help me. 60 minutes is equal to 1 hour. That's another relationship of time that might help me. There are 24 hours in a single day. Okay, maybe we're getting closer, right? At least our time is getting bigger. And we also know that there are 365 days in 1 year. Now, if I want to, and I'm just going to minimize this a little bit so that we have room, right? There are our relationships that we can use. If I want to set this up so that I'm able to go from seconds to years, I'm going to follow my process just the way I did, except I'm going to keep adding conversion factors to my equation, to my math that I'm doing, until I get from the unit I have to the unit I want. So I'm going to start with the unit I have, 4.5 years, putting that over 1. And then I'm going to come over here and I'm going to look at my relationships and I'm going to say, do I have something that has years in it so I can get rid of years? And the answer is yes. I have my relationship of 1 year, 365 days, which I'm going to abbreviate with a D just for ease. So I can cross out years, and so I'm making some progress. But I don't want to answer in days. I want an answer in seconds. So my next question is, how do I get rid of days? Well, I have a conversion factor over here that says for every 1 day, I have 24 hours. Well, that's good because now I can get rid of days. I'm closer to seconds. I'm not quite at seconds. I'm at hours, so I need to do a little bit more work. Do I have a conversion factor that takes me from hours to something that's closer to seconds? Yes, I do. 1 hour is equal to 60 minutes. So I'm getting closer, right? I'm getting smaller in terms of my time. I can get rid of hours, and now I'm in minutes. And if I look, right, I just used that one. Here's my last conversion factor of 60 seconds for every 1 minute. Minutes are now gone. I've crossed out every unit except seconds, and now I can solve, right? My answer is going to be in seconds. And if I plug this big, long collection of things into the calculator, 4.5 times 365 times 24 times 60 times 60, I wind up with 1.41912 times 10 to the 8. Mind you, we're not concerned in this moment about significant figures. I'm only showing you the process of dimensional analysis. Of course, we could also figure out what to round to if we used our understanding of 60 minutes, of significant figures. Sort of the last level of challenge here is going to be to deal with substances or conversions that don't have a single unit involved. I'm not going from a single unit, let's say, of length to another single unit of length. So here I'm looking at an equation where I'm being asked to go from 60 miles per hour. So my given information is not 60 miles over 1, but it's actually over another unit. And I'm being asked to change that relationship into feet, which is an English measurement of length, per second, which is a smaller measurement of time. We do the same things, and I like to tackle one of my units at a time. So let's say I want to get from miles to feet first. Well, let's talk about what we know. I know that there's 5,280 feet in 1 mile. So I'm going to take my given information, I'm going to write it down, 60 miles per hour. It's my first relationship. And I'm going to set up my conversion factor of miles to feet with 1 mile going at the bottom because I want miles to cancel, and 5,280 feet going on the top. So when I cross out miles, my end answer in this moment is going to be in feet per hour because those are the 2 units that I have left. I don't want my answer in feet per hour. I want my answer in feet per second. So the question is, how do I get from hours to seconds? So we can go back and look at the relationships that we used in the previous equation, right? 1 hour, 60 minutes, getting closer to the amount of time we want. And then 1 minute, 60 seconds. Hour on the bottom, hour on the top, minute on the bottom, minute on the top. And then what I'm left with now, my only numerator value in terms of, or my numerator unit is feet, everything else is canceled, and my denominator unit is seconds. So now when I solve mathematically, I'm going to wind up with feet per second in my answer. So we also have a slight difference here in that I have some numbers in the denominator. So again, what's happening here is you're going to multiply all of your numbers across the top. So I'm going to have 60 times 5,280 times 1 is really what's happening. And then my number on the bottom is 1 times 60 times 60. And then, of course, I want to simplify those values. So if I plug into the calculator 60 times 5280, I'm not going to plug in the ones, I'm going to get 316800. And then if I multiply across the bottom 60 times 60, that's going to give me 3600. And then I can simplify, right? I know that I don't have to use those zeros. I have 3168 divided by 36, and that's going to give me 88 as my number. And that's going to be 88 feet, because that's my numerator unit per second. So this video is giving us sort of the reminder of the general process of using dimensional analysis in order to convert between units. A reminder that in order to do it successfully, you need to be able to use factors of 1 or proportional relationships that are equal to 1. We need to pay attention to how we orient them in our relationship, so whether we're using a factor, a conversion factor, or its reciprocal, and we need to be cautious of our math as we go across.